Good day, friends, and you are again welcome to another WASE online experience. My name is Philip, and I'll be your instructor for today. But before we start our activity for the day, I'll need you to subscribe to our channel if you've not already done that. Remember, once new videos are created, you'll be sent an alert if you have subscribed to this channel. To be able to do this, you simply need to go below the video and tap the subscribe button. Alright, thank you very much for doing this for us. Let's look at our activity for the day. In today's lesson, we will be looking at the part 2 of algebraic expressions, and under part 2 we will be looking at operations on algebraic expressions. Under operations of algebraic expressions, we will be looking at addition, subtraction, multiplication, division. Then we'll look at removal of brackets. Afterwards, we'll combine all of the operations together in a single question, and we'll solve that or those single questions. Let's start with addition. With addition, we would start with our first example. Example 1. With this example, we have been given the algebraic expression 5x plus 4 plus 9x plus 3x plus 2y plus 7, and we are to add the various terms of this algebraic expression. Let's note that when you are given something like this, the simplest way to go is to rearrange the terms in such a way that all like terms are on one side. So that's what we are going to do, the first step. So we are going to rewrite this this expression in such a way that like terms are on the same side. When we do this, we would get 5x plus 9x plus 3x plus 2y plus 4 plus 7. Let's note that the 5x and the 9x and 3x are of the same kind, so they are like terms, whilst the positive 4 and the positive 7 are also like terms. Positive 2y is on its own. It is not a like term to any of the terms, so that's why it is standing on its own. As simple as that. Next, we are going to add the like terms together. So we are going to add the 5x and the 9x and 3x together. When we do that, we would also add the 4 and the 7 together. So when we do this, we are going to get 17x plus 2y plus 11. Remember, 5 plus 9 plus 3 would give us 17, whilst 4 plus 7 would give us 11. The 2y is on its own, so that's what you find there. Since there isn't any more like terms that can be added, we'll leave this as our final answer. So the final answer is 17x plus 2y plus 11. As simple as that. Let's look at example 2. In this example, we've been given the algebraic expression 5x squared y plus 9xy squared plus 3x squared y plus 4xy squared, and we are to add the various terms of this algebraic expression together. So let's quickly do that. Our first step would be to rearrange the terms of this algebraic expression in a way such that all like terms will be on one side. When we do this, we would get 5x squared y plus 3x squared y plus 9xy squared plus 4xy squared. After doing this, you realize that the terms 5x squared y plus 3x squared y are alike, so they are like terms. Also, plus 9xy squared plus 4xy squared are like terms as well. At this point, we would have to add all of our like terms together. So what this means is that our 5x squared y plus the 3x squared y will be added together, and that would give us 8 squared y. Also, our plus 9xy squared plus 4xy squared would also be added together, and that would give us 13xy squared. So we would get the new expression 8x squared y plus 13xy squared. Let's move on to subtraction. Let's look at example 1 and the subtraction. In this example, we have been given the algebraic expression 21x minus 8xy minus 7x plus 3xy, and we have been asked to do some subtractions on this algebraic expression. So as usual, we would first group our like terms. When we do this, we would get 21x minus 7x, then minus 8xy plus 3xy. Our first like term or set of like terms would be 21x minus 7x. Our second set of like terms would be negative 8xy plus 3xy. 21x minus 7x would give us 14x, and negative 8xy plus 3xy would give us negative 5xy. That's how come we have gotten our final answer to be 14x negative 5xy. As simple as that. Let's look at example 2 under subtraction. Under this example, we have been given the algebraic expression 5m exponent 4 minus 6mn minus 9 minus 13m exponent 4 plus 2mn. So as usual, let's group our like terms. So when we do this, we would get 5m exponent 4 minus 13m exponent 4, then minus 6mn plus 2mn minus 9. 5m exponent 4 minus 13m exponent 4 would form our first set of like terms. Then negative 6mn plus 2mn would form the second set of like terms. As for the negative 9, it wouldn't have any partner, so we'll leave the negative 9 the way it is. It will stand alone without any partner. So now we have 5m exponent 4 minus 13m exponent 4. That would give us negative 8m exponent 4. Then also our negative 6mn plus 2mn would give us negative 4mn. Then we'll bring our negative 9. At this point, we do not have any like terms, so we leave our final answer as this. As simple as that. Let's move on to multiplication. So we are on multiplication, but before we look at some examples, let's look at a few things. Let's assume that we've been given the variable y exponent 4 multiplied by the variable y exponent 2. When you are given something like this, all you need to do is to maintain the variable y and add the exponent. So in this case, you'd maintain the y and you would add the 4 and the 2. The 4 added to the 2 would give us 6. So our final answer would give us y exponent 6. Let's look at another illustration. In this case, we have been given the variable m times the variable m exponent 2. Let's note that when we are given a variable without any exponent, we will need to take the exponent of that variable as 1. In this case, we've been given m times m squared. M times m squared is the same as m exponent 1 times m squared. So what this means is that we are going to maintain one variable, in this case the m, and we are going to add the exponent. We would add the 1 to the 2. 1 plus 2 would give us 3. So what this means is that our final answer will be equals to m exponent 3. Now let's use the illustration we've just looked at to solve some examples. Let's look at example 1. In example 1, we have been given 5mxy exponent 4 multiplied by 4x exponent 4y exponent 2. When you are given something like this, you first need to multiply the numbers, then you multiply variables. So in this case, you multiply the 5 by the 4. When you are done, we would ask ourselves whether there is another m on that side. It looks like there is only m, so that m will be maintained. Then we take the x. That x, the one by the coefficient 5, is exponent 1. So we multiply it by the one on the other side, which is x exponent 4. Then afterwards you take the y. That y by the coefficient 5 is exponent 4. So we would multiply it by the second y, which is exponent 2. So that's what we are going to do. So let's start. The 5 multiplied by the 4 would give us 20. So that's what you see there. Then we have m, so we write m. There is no other m, so we write the m like that with the exponent of 1. But we don't write exponent 1, so we just write m. Then we have x exponent 1 multiplied by x exponent 4. So we would add the two exponents, 1 plus 4. That will give us x exponent 5. Then we take the y. The y is first exponent 4 multiplied by the second y, which has exponent of 2. So we add 4 plus 2. That will give us 6. So that y will be exponent 6. As simple as that. So the final answer will be equals to 20m x exponent 5 y exponent 6. Let's try example 2. For this example, we have been given 5h exponent 2x multiplied by 2x y exponent 3 multiplied by 3h exponent 7y exponent 2. So as usual, we would have to multiply all of the numbers, then we'll come to the variables. So first we'll multiply the 5 by the 2, then by the 3. When we do that, you get the number 30. When we are done, we will take the h exponent 2. We move to the next, there is no h. We go to the next, there is h exponent 7. So we have h exponent 2 times h exponent 7. That will give us h exponent 9. So we are done with the h. We would have to go to x. At the first level, we have x without any exponent, so that's x exponent 1 times the next is x, also exponent 1. The next level, we don't have any x, so we have x exponent 1 times x exponent 1. That will give us x exponent 2. So we move on to the next. We have now y exponent 3 times another y exponent 2. That will give us y exponent 5. As simple as that. Let's look at division of algebraic expressions. Under Division 2, we will be looking at the few illustrations before we move on to our examples. So let's look at the first illustration. For the first illustration, we've been given y exponent 5 divided by y exponent 2. Again, because the variables are the same, when you are given something like this, all you need to do is to maintain one variable and subtract the exponent of the variable on your right hand side from the exponent of the variable on the left hand side. So in this case, we are going to subtract 2 from 5 and we will get something like this. We would get y exponent 5 minus 2 as shown on the screen. 5 minus 2 is 3. So what that means is that our final answer for this illustration will be y exponent 3. Let's look at the second illustration. For this illustration, we have been given m exponent 6 divided by m exponent 1. Of course, the 1 wasn't written, but we know from previous illustration that any variable without any exponent has an exponent of 1. So that's why that m is having an exponent of 1. So here too would maintain the variable m and subtract 1 from 6. 6 minus 1 is 5. So our final answer for this illustration will be m exponent 5. Let's look at our third illustration. For this illustration, we've been given the variable m exponent the number 2 divided by m exponent the number 5. So as usual, we would have to subtract the number 5 from the number 2. 2 minus 5 is negative 3. So what this means is that our final answer would be m exponent negative 3. Now if we want to write the m in positive exponents, all we will need to do is to write the m first in an inverse form, which is 1 over m. Then we can change the negative 3 to positive 3 as shown on the screen. With these illustrations, let's look at our examples. Example 1. For this example, we have been given 15m exponent 7, x exponent 5, y exponent 6, all divided by 3, m exponent 3, x exponent 2, y exponent 2. And we have to solve this. So when you are given something like this, first we would have to divide the numbers. So let's take the 15 divided by 3, we would get 5. Let's take the m exponent 7 divided by the m exponent 3. So we'll subtract the 3 from the 7. That will give us m exponent 4. Then let's take x exponent 5 divided by x exponent 2. What we do is we would subtract the exponent of 2 from the exponent 5. That will give us x exponent 3. Then finally we have y exponent 6 divided by y exponent 2. So subtract the exponent of 2 from the exponent of 6, and that would give us y exponent 4. As simple as that. So our final answer is 5m exponent 4 x exponent 3 y exponent 4. Let's look at example 2. For example 2, we have been given 12h exponent 8 x exponent 5 all divided by 2x exponent 7 y exponent 3. So when you are given something like this, you first have to divide the numbers. So first we'll divide the 12 by 2, that will give us 6. We'll divide h exponent 8 by, there isn't any h, so we just maintain the h exponent 8 like that. So we'll move on to the variable x exponent 5. I will divide x exponent 5 by x exponent 7. What it means, I would subtract the exponent of 7 from the exponent of 5. That will give us x exponent negative 2. Then again, there isn't y on the left side. So what it means that we would have to divide whatever you have there by y exponent 3. Now if we want to write the whole expression again, but with x exponent being positive, all we need to do is to bring the x to the denominator side. So we make the x a denominator, then we change its negative exponent to a positive exponent as shown on the screen. And when we do this, we would get 6h exponent 8 divided by x exponent 2, then y exponent 3. So that's our final answer. Now let's look at how we can remove brackets in algebraic expressions. And the removal of brackets, we'll be looking at the first example, example 1. And in this example, we have been given the algebraic expression 5x squared into bracket 4 minus 6x squared plus 3x exponent 3y bracket closed. And we are being asked to remove bracket or solve for this expression. To be able to do this, all we need to do is to multiply the item outside of the bracket. In this case, the item outside of the bracket is 5x squared by all the various terms within the bracket. The various terms within the bracket are positive 4, then we have minus or negative 6x squared, then we also have positive 3x exponent 3y. So all we are going to do is to multiply the 5 which is outside of the bracket by all of these terms. So let's quickly do this. So when 5x squared multiplies the 4, we would get 20x squared. What happened was 5 multiplied the 4, we got 20, and we just maintain the x squared like that because there is no other variable that was multiplied. So that's how come we got the 20x squared. Again, the 5x squared would multiply the negative 6x squared, and here what would happen is that 5 would multiply the negative 6, that will give us negative 30. Then the s squared would multiply the s squared, that will give us x exponent 4. We added the two 2's, that's how come we got 4. Finally, the 5s squared would multiply the positive 3x exponent 3y. First, the 5 times the 3 will give us 15, that's positive 15. Then x exponent 2 would multiply the x exponent 3, so we'll add a 2 and the 3, that will give us x exponent 5. then we would have to write the y. There is no other variable to multiply that y, so we'll maintain the y there like that. So that's our final answer, and it's as simple as that. Let's look at example 2. And in example 2, we've been given negative 2y. Then we have our bracket 5xy minus 4my exponent 2, a bracket closed. Let's do this. Again, in this case, we'll multiply the item outside of the bracket by the items or the terms within the bracket. So here, the negative 2y would multiply the 5xy, then afterwards it will multiply the negative 4my exponent 2. So when we do this, first the negative 2 would multiply the 5, that will give us negative 10. Then the y will multiply the y within the bracket, that will give us y exponent 2. Then we write the x, so that will give us negative 10 x y exponent 2. That's how come we got that figure. Again, the negative 2y would multiply the negative 4my square. So first negative 2 would multiply the negative 4, that will give us positive 8. Then the m will be maintained since there is no other m. Now we have the y exponent 1 would multiply the y exponent 2. That will give us 1 plus 2, that will give us 3. So that will give us y exponent 3. So our final answer is negative 10 x y exponent 2 plus 8m y exponent 3. And I believe this was also very easy to do. In our next slide, we are going to combine all the items we've looked at. So we combine addition, subtraction, multiplication together with removal of brackets and everything together to solve problems in the next slide. So let's look at that quickly. So now let's look at how we can combine all of the operations. So let's look at example 1. In example 1, we have been given 3 into bracket x minus 4y bracket closed. Then we have minus, then another bracket 2x plus 3y bracket closed, and we are to solve this. We will start by first removing our bracket. So we'll be, in this case, we'll remove the first bracket. In the first bracket, we have x minus 4y. Then we have the number 3 outside of the bracket. So 3 would first multiply the x, that will give us 3x. Then again 3 would multiply the negative 4y, that will give us negative 12y. Let's now remove the second bracket. Within the second bracket, we have 2x plus 3y. And outside of that second bracket, we have the negative sign with no number in front of it. Remember, the negative sign with no number in front of it simply indicates that there is the number 1 there. So first, we would have to multiply the negative 1 by the 2x in the bracket. That will give us negative 2x. When we are done, we will multiply the negative 1 again by the positive 3y within the bracket, and that will give us negative 3y. So now we have 3x minus 12y minus 2x minus 3y. So all we need to do is to group our like terms. So we are going to rearrange that expression with all like terms on one side. When we do this, we would get 3x minus 2x minus 12y minus 3y. So now we have 3x minus 2x, that will give us x or 1x, but of course we write it as x. Then also we have the negative 12y minus 3y, and that will give us negative 15y. So our final answer is x minus 15y. As simple as that. Let's look at example 2. In example 2, we have been given q into bracket 3s plus 4t bracket closed minus 2q bracket 2s minus t bracket closed. Let's solve this. We would open the first bracket. So inside that bracket we have 3s plus 4t, and outside of that bracket we have the variable q. So first the q would multiply the 3s, that will give us 3qs, and again the q would multiply the 4t, that will give us 4qt. Let's now open the second bracket. Inside of this bracket we have 2s minus t, and outside of this bracket we have negative 2q. So negative 2q would first multiply 2s, that will give us negative 4qs. Again the negative 2q would multiply the negative t, that will give us positive 2qt. So we now have 3qs plus 4qt minus 4qs plus 2qt. I believe we can now rearrange them so that like terms will be on the same side. Let's do that now. When we do that arrangement, we would get 3qs minus 4qs plus 4qt plus 2qt. At this point, it is easier for us to add and subtract like terms. So 3qs minus 4qs will give us negative qs. Remember, 3 minus 4 will give us negative 1. So that's how come we have negative qs. There is an imaginary 1 in front of the qs. Also, the positive 4qt plus the 2qt would give us 6qt. As simple as that. So the final answer will be equals to negative qs plus 6qt. Let's move on to example 3. Let's look at example 3. In example 3, we have been given 10a plus 7b minus into bracket 2a plus 3b bracket closed. The first two terms of this expression, that is 10a plus 7b, are not in a bracket, so you can repeat them the same way they appear. When we do that, we would get 10a plus 7b. The remaining part of the expression you find in brackets. So we have 2a plus 3b, all of them are in bracket, and outside of that bracket we have the negative sign. Remember, because there is no number in front of that negative sign, we would have to put an imaginary 1 there. So what this means is that we have negative 1 multiplying the 2a within the bracket. When we do that, that will give us negative 2a. Then again the negative 1 would multiply the positive 3b within the bracket, and that would also give us negative 3b. As simple as that. So we now have the expression 10a plus 7b minus 2a minus 3b, and all we need to do is to rearrange them so that like terms will be on the same side. So let's quickly do this. When we do this, we would get 10a minus 2a plus 7b minus 3b. So our 10a minus 2a would give us 8a. Then our 7b minus 3b would give us 4b. What this means is that the final answer would be 8a plus 4b. As simple as that. Let's look at example 4, our final example. So in this example, we have been given 5 times 4s minus 9s minus 3y times 2. So let's jump into it. So first we have 5 times 4x. 5 times 4x will give us 20x. So let's write that first. The remaining expression, which is negative into bracket 9s minus 3y times 2, can also be written as negative 2 into bracket 9s minus 3y, bracket closed. So let's rewrite our 20s. We would then expand the bracket. The items in the bracket are 9s minus 3y, and the item outside of the bracket is negative 2. So negative 2 would first multiply the 9s, and that would give us negative 18s. Again, the negative 2 would multiply the negative 3y, and that would give us positive 6y. So at this point we have 20s minus 18s plus 6y, and here it seems as if the like terms have already been arranged in the proper format. They are already on the same side, so we can go straight that way and solve our problem. So we have 20s minus 18s, that will give us 2s. Then our 6y is just 6y, so we just repeat it as positive 6y. As simple as that. Our final answer is 2s plus 6y. Well friends, at this point we would bring part 2 of algebraic expressions to an end. In our next meeting, we'll be looking at the part 3 of this topic, and under the part 3 we'll be looking at how to form algebraic expressions from word problems. Thanks very much for staying with us. And please, I'll need you to subscribe to this channel if you've not already done that. Remember, once you subscribe and new videos are being done, you'll be given an alert of those new videos. Stay safe. We'll meet again in our next class.